My name is Lucas. Many of you have probably already talked to me or spoken to me or potentially even met me. And I'm the education director here at Fidgets, and I'm also an engineer. So today what I'm going to be doing is I'm going to be reviewing advanced sensors with Python. And here is our schedule for today. So the first thing I want to talk about is what are Fidgets, and I'm just going to do it really briefly because I know at this point a lot of you already know what Fidgets are. But I just want to do a really quick overview for in case someone maybe hasn't done the online course for the Getting Started kit. So many of you, most of you, maybe all of you have this already in your hands, and maybe you've actually gone through the course, but some of you may not. So I'm going to go through that really quickly. I'm going to make sure everyone knows how they can get that kit. So if you have not received this yet and you want to receive one, I will let you know how to do that, and I will also let you know how to claim your sensor. So we are giving away sensors as part of participating in these webinars, these advanced sensor webinars. So it's a really good way for you guys to get more hardware into your classroom and also learn about how to use these and the different ways you can use them. We'll next review how to use the Getting Started kit. So again, this is going to be a really brief overview. So just like 2 seconds on the course and where you can find the course for this thing and what resources there are for it. And sorry, people are still joining as we're going. So if I'm kind of stuttering, that's why. Thank you for joining us, everyone who just has. After that, I'm going to be actually showing you how I would use the Sonar and the light fidget. So that is the light fidget is this guy. It looks like that. And then the Sonar fidget looks something like this. Sorry, people are in the waiting room, so I gotta let them in. So this is what the Sonar fidget looks like. So these are the two sensors that we are kind of offering as part of attending this webinar. And you guys have probably already at this point picked those, but I'll show you, I'll talk more about that in a little bit. So I'm just gonna show you how I would actually program these things, the steps to do that, and what resources are available on the education website. And then finally, I kind of want to do something a little bit more fun with these webinars. So I created this project behind me that you can kind of see right here. So this is a jack-o'-lantern that I have modified with Fidgets to create like a smart jack-o'-lantern, or like a you know, you've always seen those like Halloween projects that move when someone approaches and things like that. That's what we're going to be doing today, and I'll show you the resource for that on the website as well. Okay, so if you're just joining us, this is the link for the webinar, bit.ly/fidgets_webinar, and if you'd like, you can write that down. Okay, so I'm going to quickly start with what are Fidgets. So if you are brand new to Fidgets and you don't know what they are, the basic idea is that they're programmable USB sensors. So as I just kind of showed you guys, this is what most Fidgets look like. So they fit in the palm of your hand, pretty small, and each one does a different thing. So this is a light sensor. This one here is a distance sensor, and we have hundreds of different kinds of sensors, and they all do different things. So what you do is you take one of our cables that looks like this, you plug it in. So I'm plugging in the light sensor. You take the VIN tub, so that is this guy. This is kind of like the brain of any Fidgets project. You plug your light sensor into any of the ports. So there's 6 ports. So I'm going to plug that in. And then what you do is you take a USB cable, just a standard USB cable, and you plug it into the VIN tub, and you plug this into your computer. So basically, light sensor goes to VIN tub goes to computer, and then what you do is you write code. So you write code in Java, in Python, in C#, in Swift, in whatever language you like. So the idea is that we're not trying to, sorry, more people are coming in. We're not trying to kind of like force you into a specific environment. The idea is that if you are using Java or you're using Python, this is something that you can use with Python that allows you to do some really cool things. So aside from the Getting Started kit, one thing I really want to point out is many of you have this. This is not all that Fidgets are. We have kind of created this project, created the box with the LEDs and the sensors, and inside you can see the VIN tub that I just was talking about. But this is just one little application of what you can do with Fidgets. In reality, there's hundreds of different Fidgets. So if you have a project in mind, you can probably do it with Fidgets. The really cool thing about Fidgets is that they are used by STEM professionals. So engineers, computer scientists, researchers, they've been buying Fidgets for the last 20 years. and have been using Fidgets. So you've probably interacted with Fidgets in some way without even really knowing. Not happening much lately, but if you've crossed the border when you're on an airplane, if you've crossed like the US border, there's Fidgets in those machines that scan your passport. There's Fidgets in there. There's Fidgets roasting coffee all over the world. So if you've ever had artisanal coffee, it's probably roasted by Fidget. So there's a lot of cool examples. I've listed a few here, so I won't go through them now, but the first one is a researcher from Cambridge who uses Fidgets, and the other one is actually just, I believe it's a slideshow that I made with just some kind of a list of examples. And what we're doing now is we're trying to get an industry example every month. So we have a monthly newsletter that some of you may have seen. And what we're doing with that is every month we're going to have a new video of an engineer or a researcher, and they'll be talking about how they actually use Fidgets in their careers. Okay, using the Getting Started Kit. So I just really wanted to briefly touch on this to make sure everyone actually understands, because I've had a lot of teachers who are basically putting this together and they're trying to create their own content for it. So just so everyone knows, the way to do this is on the box here, you'll see fidgets.com/start. So that is where you want to send your students. So fidgets.com/start. And that will bring you to the Getting Started Kit tutorial page. So this is what it looks like. You start at step 1. It shows them how to build the kit. Step 2 is configuring the kit, and then it shows them how to actually use every element. So there's LEDs, there's LEDs, buttons, and there's a temperature/humidity sensor. So this will teach them each kind of part of that, and there'll also be projects and kind of like opportunities for assessment. So that's how you would actually work through this if you haven't worked through it yet. And then at the end, actually, we just added this last month. There's this advanced lessons tab. So as I mentioned, like it's a professional tool. The exact tool, like the exact same things, this light sensor, the sonar sensor, these are the exact same things we're selling to professionals. So there's actually a lot of really cool things that you can do with Fidgets, but we just haven't shown students yet in the kind of beginning stages. We really want to keep things simple when they start, but the advanced lessons are really good if you have a student who is kind of trying to go to the next step or they want to do like a bigger project. I would throw them at the advanced lessons section and let them work through that. So it's a really cool way to kind of start to learn a little bit more of like the next layer of Fidgets. So if you haven't done the Getting Started Kit, that's where you want to be. And then the other thing too is on this news tab up here. So let me see if this, maybe I don't want to do that. Okay, I was gonna draw around it, but anyways, on the news tab right here, if you click on this, this is where some of you may have already seen, some of you may have signed up for this webinar here, but if not, this is where you actually can go see past webinars. So if you want to use the Getting Started Kit with Python, here's like the most recent Getting Started Kit with Python webinar. So it's just like we're doing here, and you can kind of scrub through it at whatever rate you want and get the information you need. So again, if you haven't gone through this yet, I would highly recommend checking out the course and checking out one of the webinars. The next thing that we are going to do is, so we've gone through these now. So we're about 20 minutes in and we've gone through these. So the next thing I want to do is, this is really getting into the like advanced sensors section, is I want to show you guys how you would actually use these advanced sensors. So when you get the light sensor or when you get the sonar sensor, this is how it works. So I'm going to start with the light sensor. So again, it looks like this. And what I'm going to do is show you on the website where I would go. So for example, your students have completed the Getting Started Kit. They're looking for the next thing to do. This is what you would throw at them. So fidgets.com/education. Okay, so I'm going to go to the Learn tab. So this is another way that you can get to the Getting Started Kit page, is from the Learn tab, and then you can navigate to level 1. But now we're working on devices. We're done with the Getting Started Kit, so we're going to level 2. So here is the device tutorials page, and what you will see here is 8 sensors that we have handpicked from our catalog of sensors. So I mentioned we have a lot of different sensors. What we've done for education is we picked 8 of them that we think are a really good like next step after the Getting Started Kit, and we've created content here. So again, I'm using the light sensor. So what I want to do is I want to find the light sensor, which is right here, and I want to click through that. Okay, so this is going to bring me now to the light sensor page. And what I have here is something that looks very familiar, very similar to the Getting Started kit. So the students will be familiar with it. So here's the fidget that I'm using, and here's a little breakdown of what it does. So again, the light sensor, just like you would imagine, it measures light, it measures brightness, and it measures it in something, it returns a value in illuminance, which is lux is the symbol, and it tells you how much light there is per square meter. So if I go down, this is what my setup should look like. So I'm going to do that right now. So I have my VinTub, just like in the picture. So VinTub, and I'm going to connect it to my light sensor, which looks like this. And I'm going to plug it in like that. So boom, plugged in. And then I'm going to plug in my USB cable, which is connected to my computer. So now I have that same setup here. Sorry, I'm just going to admit someone in the waiting room. So now I have the same sensor here, or the same setup here that I have there. And then I can scroll down and I can get my code. So just like in the Getting Started kit, I have this button here that allows me to set my programming language and my development environment. So if I click on this, it gives me all the options. If you're using an environment that's not listed here, let us know and we can add it. But for today, I'm going to be using Thonny, which is a really nice programming environment. So I'm going to open up Thonny, which looks like this. Clear that. So this is what Thonny looks like. In order to use Fidgets with Thonny, the first time you would open this, you would go to Tools, Manage Packages, and then you would search for Fidget 22 Native and search, and then you would install it. So if you're using a different environment for Python, like PyCharm or like any, there's a million different ones, but basically most of them have a pip like section where you can install packages using pip. So you would just search for Fidget 22 Native, press install, and then you're done. So that will kind of pull down everything you need to work with Fidgets. You don't need any kind of administrator privileges or anything to do that. Anyone can do that on any computer. So now that I have Thonny configured, what I'm going to do is I'm going to look at this code here. I'm going to copy it and I'm going to paste it in. Oh, I'm going to make a new file. I'm going to paste it in and I'm going to press run. So this will prompt me to create a new file. So I'm just going to call this light.py and then it'll start running the program. So hopefully everyone can see that. I'll make sure my chat is up just in case anyone has questions. And that is basically now spitting out the light sensor values from this guy. So if I cover it with my hand, you will see those drop down to near 0. And if I, release it, there we go, it's back up. So it's a really good way, really easy way to detect. I mean, you could actually log this and say, hey, here's exactly how much light is in the room. But if you just wanted to do something like, hey, I only want to turn on the pumpkin, like say I have LEDs in it, which I do. I only want to turn that on when it's dark out. This would be something you would use and say, hey, okay, when the light kind of goes down and it's dark out, now I want to enable this project. I'm going to quickly go through the code just so that everyone can have a brief overview of what's happening. So every Fidgets project, you'll have this import statement for Python. What this is doing is when you did the pip install Fidget 22 native, it pulled down all of the library files from Fidgets, and now we're just referencing them. So I want to use, you're always going to have to use the Fidget 22.fidget, and I'm using a light sensor, so I want to import the light sensor class. That's all it's doing. We have a time import because we use time down here, so nothing's Fidget specific there. And then, there's only really three lines of code for Fidgets. So the first line, I am instantiating my object. So I'm saying, hey, I'm using a light sensor, so I want to create a new light sensor object. That information that it's a light sensor is given in the code. On the actual physical device, I'm not sure if you guys will be able to see that, but on the top right for the sonar, for example, there's a label that says object, and it tells you which object you have to use. So if you just need a really quick reference, it's always on the enclosure. So that's my first step. The left side is just a variable name. So I could have this to be X. Oops, if I stop my program, I could call this X, I could call this Y. It doesn't matter because it's just a variable name. The right side is what is actually referencing that Fidgets class. After that, all I have to do is open it. So this is what is now making the connection between the hardware object and the software object. It's saying, hey, I want to look for like a light sensor connected to my machine. Does anyone know what the 1000 means, or does anyone have questions about the 1000 means? So there's a few quick questions in the chat. I'm going to get to these right after this section. So Allison says that the open wait for attachment is a time delay, which is partially correct. Exactly. So Matthew says 1000 milliseconds. This is also correct. So basically, what this is doing is it's saying, I want to open this light sensor, and I'm going to give you like 1 second, 1000 milliseconds to find it. So what can happen sometimes, like we have customers who use hundreds of different fidgets in a single project. So like there's a time delay that's involved with that. So they might want to make this, 60 seconds or something just to make sure that everything is attached. For students, because they're only really using 1, 2, 3, 4 sensors, 1000 is usually adequate, but that's all it is. So if one way you can test it is if I unplugged my fidgets and I ran this, let's make this 3 seconds. So it should take 3 seconds for this thing to spit out an error. So if I say 1, 2, 3, I should get an error right there. So we can see an error saying, no fidgets were detected at all. So that's all that is. It's a delay. If I set that to 60 seconds, it would have taken 60 seconds before I got that error. So it's just giving the thing time to find the device. But in reality, all you guys need to do is basically set that to 1000 and you should always be good to go. So after we've passed through this line of code, we will get onto the while loop. So now that means that the light sensor is attached and we can actually use it. So the next step is to just simply get illuminance. So this is the piece of code. This is the method that you would use if you want to actually read data from this light sensor. And that's what we're using to get the value. So really pretty straightforward, 3 lines of code, and a really cool way in Python to get data about lights. So after the students have kind of ran this piece of code, they would then go back into this web page here, and then they would scroll down and it will give them some applications. So this one says something about, if you have a phone, it probably has a very similar light sensor, if not the exact same one, in it that is controlling the brightness and stuff like that based on the environment. It talks about some other examples, but it kind of relates into them like, hey, this is something that is actually really widely used in real life. And this is, now you kind of have an idea of how it actually works. And then after that, there's practice. So again, Shell was mentioning before, like about assessment and what can I kind of do to actually, because the whole thing has to tie back to assessment, obviously. So this is a way where you could say, okay, I'm gonna give you the light sensor, go through this page, and then come back to me with these, like how did you get 1 done? Did you get 1 and 2 done? And that will give you an idea of how they actually did this. And we have solutions for anything on the website has solutions for teachers. So if you email us at education@fidgets.com, we can always send you solutions so that you have something to reference. Okay, so that is the light sensor project. I'm gonna swing quickly to the chat so that I can see if there's something I can answer. If anyone has questions at this point too, feel free to ask in the chat or just jump on the mic. Let's see if there's another question. Do you know if so Allison's asking about Mu. So I've used Mu on the Raspberry Pi and I got it to work on that. So I will look into that and see, because I'm not sure if you can just use Mu. Could I just download Mu right now? Like, I'm not sure how that works. Okay, so then Jennifer's asking about integrating Fidgets with Raspberry Pi. So yeah, you can do that right now. We're actually making that process a lot simpler. But if you guys have specific questions like this too, and you actually want a legitimate follow up with like a lot of information, email me. I'll put my email in the chat, and I'll just make sure everyone gets followed up with. And then Peter's asking about documentation for different fidgets. So, how did I know that the piece of code here was get illuminance? So what we're doing right now is we're actually in the process of adding like basically an API to the device page. So what will happen is you'll scroll down here and there'll be a thing here that has the device API. That's kind of advanced. A lot of people don't need to even think about that. But if you do, or if you're wondering about that right now, what you can do is you can go to fidgets.com. So this is where our kind of professional users would go. And then you could search for the device. So this device is a Lux 1000, it says on the enclosure. And then you would click on this API tab. So this is where you would pick your language, like, hey, I'm using Python, and it will give you all the functions and everything related to it. We're going to be putting a simpler version of that on the device page. But again, if you don't know what that means, don't worry about it. You don't need it. This is all you need. The code that you need is going to be right here. But if you're an advanced user, that's where you would find that. Okay, so I'm going to now switch from the light sensor. So I'm going to unplug it. So there's tabs on the device. So if you push on the tab and pull down like that, that's the best way to get the device to detach. So there's like a little tab. A lot of times students won't recognize that and they'll just try to pull it out. But the best way is to just apply downward force and kind of like slide it out like that. And then I'm gonna attach the sonar fidget. So boom, like that. And now I'm connected. And then I'm going to navigate back to device tutorials. So learn, device tutorials. And I'm gonna find the sonar sensor. So this is the one we're looking for. So I'm gonna click through to that. Okay, so exact same format as the last one. Gives you a little bit of a breakdown of what this thing does. So the very basic overview of this is it's a distance sensor. So it will tell you how far or how close you are. And the range is 40 millimeters to 10 meters. So that is the range, and that's like 30 feet, I think. So pretty decent sensing range. I'm not sure if it can actually go all the way to 30 feet, but we can test it. So this is what the setup looks like. So again, I have that exact same setup here. I have a slightly longer fidget cable, but this is what that will look like. And I have it plugged into my computer. And then we have the code section. So again, just like the light sensor, I'm gonna copy this code using this button up here. You can also just highlight this and copy paste. And then what I'm gonna do is I'm gonna go back to the exact same project. I'm gonna Control A to highlight everything, and I'm gonna Control V to paste on top of it. Okay. And then what I'll do first is I'll run this just so everyone has an idea of what you can expect. So I have it sitting on my desk. It's pointing at the ceiling, which is approximately 2 meters away. And if I put my hand in front of it, we can get updates showing how far my hand is. So again, you could use this for a specific purpose. If you really want to know how far away something is, or you want to try to measure something, if you want to try to measure how tall you are, you could point it down, or you could use it as an approximation, which is what we're going to use for the pumpkin project. We're just going to say, hey, like, did this thing detect someone? So a couple different use cases there. And if we look at the code here, we are going to see the exact same. Is there a quick way to code a distance versus time? Actually, you know what's really cool about Thonny? Let me see if this works. So Allison on the chat was asking about distance versus time. See, I'm not sure why it's not happening here. I got to figure this out. On a lot of times in Thonny, you can actually you can view there's a plotter like built in, but I don't know why it doesn't show up sometimes. Like, I don't know if I have to enable it or what. Maybe someone else would know that. But I mean, one way you could do it is, oops, did I just break this now? Let's see, is that still running? I'm still running. Okay, so one way you could do it is, depending on what language you're using, I know there's a lot of like packages that make it really easy to graph things. So for Python, which one is, I think Python, you can use something called core plot or matplotlib or something like that. Someone might be able to correct me in the chat, but you could basically import a third-party package that like graphs things really easily and do that. Or you could even honestly just export this to a like an Excel. Like, you could export the data here really easily to a spreadsheet, and then you could actually graph that. Yeah, Jeff's got it. Matplotlib, that's what I was thinking of. And I think that's for Python, which makes it really easy to graph things. But there's a lot of yeah, Python, cool. So there's a lot of different ways to do that. And actually, you know, that's probably a good option for a project. So, okay, I'm gonna disconnect this now. It's not letting me. I think I messed up my Thonny thing. Yeah, clicking on too many buttons here. Not sure why. Sorry, I think I just killed Thonny. Let's see. Okay, what I'm going to do quickly is I want to talk about the. Oh, I think I just have two windows open that I'm not noticing. Oops. Okay, so what I want to quickly do is talk about the code again. So very similar thing. Yeah, I think I had two windows open and then I just didn't realize it. Very similar to last time. I'll actually just expand this so everyone can see better. So we have the import. So as I mentioned, you'll always have that Fidget import. And then we have the distance sensor import. So again, the object we're using is distance sensor. It's printed on the enclosure. So we're using that class, sorry, the distance sensor class. Doing the exact same thing here. We're creating the distance sensor object. So hey, we want to use the distance sensor. So we called it distance sensor here. You could call this whatever you want. If you're using it to detect motion, you could call it motion detector, whatever. Again, we're opening it. We're giving it that 1 second delay to try to find it, and then we're using it. So this sensor has default units of millimeters, but I think one of the, let me see, I think one of the questions is potentially converting the units. Maybe not. Okay, but anyways, what you could do with this, if you use a different unit as your base unit where you are, one cool thing you could do is just do unit conversion. Like, hey, now make this thing print in inches. But yeah, so default units are millimeters. And again, just like the light sensor, we have the application note. So, you know, this is a similar technology to things that you might see in cars where they're detecting other cars coming by. And some other applications here are listed here. And then again, we have the practice. So this is something that you would say you bought a few sensors, sonar sensors for your classroom. You could actually turn that into a day or two maybe of work for the student, where you can actually assess how much they've completed. So that is the sonar sensor. If anyone has any questions, then, so Jeff says he tried Mu, did not recognize Python Fidget 22 library. Okay, so I mean, if Jeff didn't get to work, then maybe there's something else going on there because he knows what he's doing. But I will also try it out and see if I can figure something out. Okay, so the next step now is, if we look at our schedule, so we've completed using the sonar and light fidget. If anyone has any questions about the sonar or the light, let me know now before I transition into the Halloween project. Okay, so Jeff is saying you might just be using its own Python 3 installation. So that means it'll probably work. We just have to figure out where its specific folder is and all that stuff. So, but I had got it working on the Raspberry Pi at one point. So if no one else has any questions about the light sensor or the sonar sensor, we will move on. Okay. Alrighty. So the next step is, so at this point, if we can imagine, you've given the student a getting started kit, they've worked through it. You've given the student a sensor like the light sensor or the sonar sensor. They've worked through that on the device tutorials page. So now the next step is, we like to call it level 3. So if we go to the Learn tab and we go to level 3, we'll see this projects section. So this is basically, okay, you know how to use a getting started kit. You know how to use individual sensors. So you've done the light sensor by itself. You've done the, all these sensors by themselves. Now the next step is, okay, let's combine these and make some larger projects with them. So if I click on the projects tab, it will bring me to the projects page, which will show a list of the available projects. So what I want to do today is I want to go to this new project here, this Halloween Scare project. So we've just made a little project for October to kind of have some fun with Halloween. So if we click through that, it'll bring us to the project page. Okay, so again, very similar format to what we've seen before. We have a little description of what you'll be doing and an image kind of give you the students some insight on what they'll actually be doing. So if we scroll down here, the idea with this project was we want to combine elements of the Getting Started kit with a different sensor. So in this situation, we used the Sonar Sensor, which is the one we just used, but actually there's some good potential for the light sensor in this project as well. But again, here's the parts list, so the student knows what they'll be working with. So the assembly for this project is not extremely in depth because it's going to depend on how you actually apply these elements. So in this situation, what we did was we took a little pumpkin, and actually probably easier to see it here, it's the same one. So as you can see here, we added the LEDs from the Getting Started kit to the eyes. We used 2 Getting Started kits, so we could get 2 reds, but you know, if it's red and green, it's probably fine too. And we use a sonar sensor, and then we just put a VinTub kind of inside the pumpkin styrofoam, so it's really easy to cut it up. And it was like $1 from it was literally like, it was from the dollar store, so it was like $1.50 or something. So the idea behind this Halloween project is we want to create this decoration that when someone like walks by, it goes off, right? That's the idea. So just like in other projects, what we have here is we have some base code for the student to work with. So we copy this code, we put it into Thonny, and I'm going to increase the size because I think it must not have been happy. So let's go to 20. Okay, so we're going to take that code, put it in Thonny, and then we will run it. And then let's see what we get. So we'll save this as Halloween, say, Halloween.py. Oops, oh, I gotta plug it in first. Okay, so then I'm gonna plug it into my computer and we'll run it. Okay, so what we get right now is we get the eyes going off. So hopefully everyone can see that. So again, those are just the LEDs. So students have already worked with the LEDs in the Getting Started kit. And then what we also have is we have the sonar sensor. So that is this guy. And we have that displaying data. So at this point, the code is very similar to what we've seen before. So the only difference is now we have a few more objects being used in the same program. So for example, here we have 2 digital outputs being used. So if you've done the Getting Started kit, you know what a digital output is, and you're familiar with that. So here we've labeled them left eye and right eye. And what we've done is we've addressed them. So again, this is all stuff that if you've gone through the Getting Started kit, you'll be familiar with. And then we've opened them. So very similar to any other project. And then what we do now is we go back to the project and we have some practice. So the idea with this project is, I mean, A, the students can have some fun with the Halloween thing, but B, they can also kind of customize it and do things that they want to do with it. So for example, if this is my code right here, can anyone throw out an idea of how I could, you know, maybe make, what would be like the simplest way to make the eyes go off if someone is close? You can jump on the mic at this point or chat. So Allison says a while statement. So we have the while statement here, and then like what would be the next steps? So if I wanted to say, okay, so let's pick a meter. So say my goal here is if someone's closer than a meter, so 1 meter or closer, I want the eyes to go off. Eyes should go off. So if I wanted to do something like that, which this is the question that's actually in the project, what I would do is I would do an if statement and I would say, hey, I want to take that distance sensor dot get distance, and I want to just see if it's less than 1,000 because the units are millimeters, so I need 1,000 millimeters. Yeah, exactly. Peter's saying if statement, if else if, exactly. So then what I can do is I can put this code here that turns the eyes on. I can put it inside this else or this if statement, and then what I can do is go else, and then I can turn them off. So if everyone remembers from the Getting Started kit, that would be turning the state to false. So now if we run this again, what we should get is the eyes should be off, which they are. And then if someone comes closer, so let's say like that, we have the eyes turn on. So basically what you could do is you could get a longer cable for this thing. You could put it somewhere, you know, not right on top of the pumpkin, but maybe somewhere kind of close by. And then you're using that to detect if someone's walking by and you're turning on the eyes. So that's like step one in the practice, is for students to kind of understand, hey, I can use this conditional here to turn on the LEDs. And again, the LED code, they should be familiar with this because they've gone through the getting started kit. So it's not much of a leap. The next step is to modify the code to use duty cycle. So now at this point, we're getting into something that was covered in the advanced lessons. So I mentioned that there is these advanced lessons in the getting started kit now that kind of talk about some more advanced concepts basically. So for students who are looking for some challenges, there's this advanced section in the getting started kit. So some people joined late, so just to review, if you scroll down now, there's this advanced lessons section here. So boom, and then this is the one we're going to, is the LED brightness. So in that section, it shows how you can actually use something called duty cycle to increase or decrease the brightness. So then for this step, it would be like, okay, if someone is, you know, a meter away, maybe turn on the eyes, but if they're closer, kind of increase the brightness, or maybe you have like a glowing thing. So it's kind of a fun little project. And as you kind of noticed here too, there's some really, you can do a lot of stuff with this project to make it better. So maybe instead of having it, you can see some flickers there. So maybe instead of it just being based on this statement here, maybe you could add the students could add some more kind of smarts to this code where it's like, okay, if I detect something within a meter, maybe I turn it on, but maybe I have a cool down period where I leave it on for, you know, 20 seconds so that I'm not getting this like sporadic, like kind of jumpiness here. Like maybe I want to leave it on and stuff like that. And then another part that would be really cool with this which is actually how I implemented it, is I use the Wi-Fi VinTub. So some of you may have the Rover kit right now in your classroom. So you could actually just take the Wi-Fi VinTub and use it in this project so that you can have this thing sitting in the corner of your room, or you could actually have it sitting at the, you know, the student could have it at their house doing something. So that is a Halloween project. It is up on the website, and I wanted to review it just so that everyone could kind of have an idea of how it works. And I think there's a lot of cool opportunities for stuff like this. So again, this is the whole idea with Fidgets education, is that you're getting these kind of tools, like you're getting a temperature sensor, you're getting the getting started kit, for example, but this temperature sensor does not always have to be tied to this kit. Like we really want to encourage students and schools to kind of explore, do more. Like these things can be taken from, you know, I now have this Sonar Sensor doing a Halloween project, and I could take it from Halloween and do a robotics project. And I can, you know, that's the whole idea, is that we want to reuse these sensors. We don't want to spend a ton of money on a single use thing. So
yeah, I do actually.
Awesome, thanks, Peter.
So yeah, I just discovered Fidgets last year, and it's been phenomenal. I've got a whole toolbox of different things, and so we've gotten to the point where the kids have their projects, they plug them into their laptops, they run them. What I'd like to do, and your pumpkin example is perfect for this, is sort of have these set up so that when people walk into the classroom from the block after ours, the stuff can run independently. And what's sort of the best practice for running like that pumpkin example on its own? Is it Raspberry Pi? Is it a separate thing? Like what would you recommend so that the kids' projects can be on display sort of without the device being without their personal laptop being attached to it?
Yeah, I would say definitely the Raspberry Pi. That's probably where I would go. We do have our own type device, the SBC, but I think the Raspberry Pi is really the where we should be going. And what I'm doing right now is we're getting a much simpler installation for the Raspberry Pi, so that should be available in like January. But it basically should be the equivalent of like an apt get install Fidget 22 type thing. But anyways, the Raspberry Pi is where I would probably do that. And okay, so the webinar is, yes, I think you can. I don't actually know. I guess it depends on how it's set up. But anyways, thank you guys all for joining. I really appreciate it. Please stay tuned on the news tab, and we really appreciate you guys for joining and trying it out, and also for commenting. It's awesome to get the comments and everything.